Hey everybody, Mr. Reeves here again as we take a look at Module 14 and the idea of real numbers. So what I want to do real quick here was refer back to this diagram on the real number system. So just a reminder, pretty much every number, not pretty much, all the numbers we're dealing with in accelerated math this year are real numbers. There are some numbers that are not real numbers, but we're not going to worry about those for now. So in the real number system, we divide numbers up into rational numbers and irrational numbers. So the two big categories are rational and they are irrational. All right, so irrational numbers, we just have one set of irrational numbers. An irrational number, when written as a decimal, is non-terminating and non-repeating. So we've talked about this. So any square root of a number that is not a perfect square, or the quotient of perfect squares, will be irrational. So pretty much any square root you come across is going to be have a good chance of being irrational, unless of course it's a perfect square. And our favorite irrational number is pi. Okay, so again, non-terminating, non-repeating decimals. When you put them in your calculator, they fill the whole screen. All right, they go on as far as your calculator will go. All right, but most numbers you come across are not going to be irrational. They're going to be rational numbers. And as I've said over and over and over again, a rational number is any number that can be written as a over b as a fraction, where the numerator a and the denominator b are integers and b is not equal to 0. All right, and we represent rational numbers as fractions, like I just described, as decimals. And when it is a decimal, it will either terminate or it will repeat a pattern, or we can represent them as mixed numbers. Now, within that rational number category, we break it down further. We have natural numbers, or sometimes we call these counting numbers. They start at 1 and then go up by 1, 1, 2, 3, 4, 5, 6, so on. All right. I had talked about numbers you can count on your fingers, but just keep in mind they don't stop at 10. They keep going on forever and ever and ever. All right, whole numbers, we take those natural numbers, we add 0. So whole numbers are basically the set of natural numbers plus one more number, 0. Now, when you take the opposite of those whole numbers, now you have negative. Sometimes we say negative whole numbers, but that's not really accurate because whole numbers have to be positive, right? So integers can be whole numbers or the opposite of whole numbers. We still don't have any fractions or decimals till we jump up to rational numbers. All right, and that's when you see here they have them written all as decimals, but of course they could be written as fractions or as mixed numbers. And again, they can be positive or they can be negative. All right, and keep in mind, if it's part of a smaller subset, it's part of the bigger subset as well. So everything here is a real number. All right, everything in the natural number category is a whole number, an integer, rational, and so on. All right, so that's something where students often get confused. All right, so they see 3. And I say, is 3 an integer? Yes, it is, but 3 is also a whole number, and 3 is also a natural number. All right, and 3 is also a rational number because it's part of this bigger circle. All right, okay, so let's go ahead and take a look at some problems. I'm going to skip over here to page 495 in your textbook. So let's start right here. Mark the following statement. Sorry, let me try that again. Mark wrote the following statements in his notebook. All right, choose true or false for each statement. Integers can be irrational numbers. Well, that's false, right? Integers are rational numbers. All right, they are not irrational. All integers are whole numbers. Now remember, integers are whole numbers and they're opposite. So for example, if I had -3, that's an integer, but it is not a whole number. All right, so this is also going to be false here. All whole numbers are integers. Now that's going to be true because integers are whole numbers and they're opposites, right? So whole numbers is like half of the integer set plus 0 thrown in because it's not positive or negative. So this one is going to be true. Okay, so again, if we go back to this diagram, all right, if it's part of the smaller subset, it's part of the bigger one. But if it's part of the bigger one, that does not make it part of the smaller one. So here's that number. -3 is an integer, but it's not a whole number. 3 is a whole number, and it's also an integer. All right. Okay, so let's go back here and take a look at this one right here. Look at each number. Is it between the square root of 50 and 5 pi over 2? So one of the skills you have to have, and I'm sure you remember doing practice on this, is knowing to compare numbers when they're written differently, right? So we have a number here written as a square root. We have a number here written as a quotient. Here we have a fraction. Here we have a sum. Here we have a product. And we want to be able to compare these. All right, now without a calculator, we have to estimate. All right, square root of 50. Now remember, I told you it's really good idea for you to know your perfect squares. 49 is 7, right? The next bigger square root, perfect square, above 7 squared is 49. 8 squared is what? 64, and that would be 8. So the square root of 50 is between 7 and 8, right? But it's much closer, right? Because the difference between those is only 1, and the difference between those is 14. So the square root of 50 is going to be just above 7, right? 7.1, if even that. All right, so I'm going to put 7.1 right here. All right, now what about, it's actually not even quite 7.1. All right, so what about 5 pi over 2? Now pi is approximately, let me do approximately 3.14, right? So 5 times 3.14, well, if I were to do that, let's see, 5 times 14, that'd be the same as 10 times 7, right? So this would be 5 times 3 is 15, so this is about 15.7-ish, all right? Okay, all right, and, right, because 10 times 7 is going to be the same as 5 times 14. You guys know you could do that, right? Cut this one in half and double that. Those both are equal to 70. So again, this is about 5 pi is about 15.7. And if you divide that by 2, all right, well, half of 15 is 7.5, and half of 0.7 would be what, 0.35? So we get about what, 7.85. Okay, so we're looking for numbers that are in between 7.1, and again, that's a generous 7.1. In fact, I'm going to go ahead and pull up my handy dandy calculator because I really want a little better idea of the square root of 50 if it's even going to round off to. All right, so I'm going to clear out my calculator and I'm going to go ahead and put in the square root of 50. All right, and it's 7.07. All right, 7.07. So it is 7.1 when you round off to near 1, but it's barely even that, right? 7.07. So if we had said 7.1, we'd probably be safe. All right, so now we want to know, are these in between? Okay, so let's do this one first. Again, if pi is about 3.14, right, then this would be about 7.14, a little bit bigger than that, right? Is that in between? Yes, it is. All right, 22 divided by 3. All right, so if we do 22 divided by 3, 3 goes into 22 7 times, right? 7 times 3 is 21. All right, then we put a 0. 7 goes into 10. Sorry, 3. My apologies. 3 goes into 10 3 times. 9, right? 1, And we could do this again and again and again. So that's going to be 7.3 repeating, right? 7.3, it's not approximately, it actually is exactly. Is that between? Yes, that is also between. All right, what about 3 times the square root of 7? All right, now again, the square root of 7 is between the square root of 4, which is 2, and the square root of 9, which is 3. So it's between 2 and 3, right? Well, 3 times 2 would be 6, correct? And 3 times 3 would be 9. So we are between 6 and 9. Well, that doesn't help us, does it? Because 6 would be too small and 9 would be too big. So I'm going to show you a little trick here. All right? This 3 times the square root of 7 is equal to the square root of 9 times the square root of 7. Do you guys agree with that? 3 is the square root of 9. And then I can multiply those two together and I get the square root of 63. So 3 times the square root of 7 is equal to the square root of 63. Now that's going to give us a little better idea because the square root of 64 is 8, right? Square root of 63 is just going to be a hair below that. And then the one before that, we just did this, right? Square root of 49 is 7. So do you see how we're just barely below the square root of 64? This is going to be too big. This is going to be too big. So this one is going to be no. All right? All right. And we could have seen here, well, the difference between the square root of 7 and 9 is 2, or the square root of 2. Well, it's not really the square root of 2. That's not how it works. But they're 2 units away there and 3 units away there, so we knew it was closer. But I think that's what makes it really clear there. All right? Okay, now again, I really don't mind if you're using a calculator judiciously on these ones that are super close. Just remember, do as much as you can without a calculator. All right, so I'm going to go ahead and go back a few pages. Let's see, what page am I on? 495. I'm going to go back to page 492. And we've got some more problems here. All right, so find the square root, the 2 square roots of each number. If the number is not a perfect square, approximate the decimal values to 1 decimal place. All right, remember, when you take a square root, you can have the positive square root or you can have the negative square root. The positive square root we call the primary or the principal square root, and this is the secondary square root. We often will do this and say we want both square roots. All right, now I'm going to modify this. Without a calculator, I don't expect you. We did not do it to 1 decimal place, but I do expect you to be able to tell me what 2 integers it's between and which one it is closer to. Do you remember when we did that? All right, so here we go. So 16, we want to do the square root of 16, and we want both the positive and the negative square root. So this is what we are looking for here. And the answer is going to be plus or minus 4 because the square root of 16 is a perfect square. All right, this one right here. Now, again, technically, 4 over 25 is not a perfect square because its square root is not an integer. But both the numerator and the denominator are perfect squares. The square root of 4 is 2, and the square root of 25 is 5. So we get plus or minus 2/5. All right, the square root of 225. All right, is that a perfect square? Well, hopefully that's one that you have memorized, right? So if you hadn't, let's see here. What is one that we would know? We could like estimate and come in close on this. Well, most of us probably know that 12 squared is 144, and that's too small, right? All right, if we did 20 squared, well, that's 400. That's too big. So it's between 12 and 20, and it ends in a 5. All right, how about 15? Yeah, what's 15 times 15? If I do 15 times 15, 5 times 5 is 5. Carry the 2. All right, I get 75 there, right? And then I do the 15, and lo and behold, what do I get? I get 225, all right? So the square root of 225, positive and negative, is plus or minus 15. Again, if you've got it memorized, it just is, you just know it. It's like your times tables, right? All right, this one is similar to that one, right? This is going to be plus or minus 1 over 7. Now, these two are not perfect squares, okay? So the square root of 10 is between the square root of 9 and the square root of 16. The square root of 9 is 3. The square root of 16 is 4. So if I were asking you to do a problem like this, I would say, okay, what two integers is it between? It is between 3 and 4. Which one is it closer to? Well, 9 is much closer to 10 than it is to 16. All right, so what I would expect you to do on a question is say it's between 3 and 4 and it's closer to 3. And if it were a multiple choice question, I might give you some choices, all right? But clearly it's going to be 3.1 or 3.2, something like that. In fact, I'll go ahead and just pull it up on my calculator and see what my calculator tells me. If I take the square root of 10, I get 3.2 to the nearest 10th, okay? So again, if it were a multiple choice question, I would make sure that the choices were far enough away that even if you didn't have a calculator, you know what it would be. All right, square root of 18. Okay, again, what two integers is it between? All right, well, the square root of 16 is 4, and the square root of 25 is 5. So it's between 4 and 5. Which of those is it closer to? It's closer to 4. Right? So again, it's going to be 4 point. Now, it's a little bit further away than that one was. So probably a little bit bigger than 4.2. All right. Again, I will not ask you to estimate, although I might without giving you choices. But if we go ahead and check what the calculator says, if I go ahead and put in the square root of 18, I actually get, wow, it is also 4.2. All right, 4.2. Well, not this one wasn't 4.2, it was 3.2, but it was 2/10. Okay? All righty. So that's what I expect you to be able to do without, if it's not a perfect square, tell me what two integers it's between, which one it's closer to, and if I give you choices, like if I put 4.5, that would be too big, right? Because it's not in the middle. All right, anything above 4.5 would be too big. So I'll make sure that when I give you choices on the quiz, that you'll be able to know by estimation. All right, write each decimal as a fraction in simplest form. All right, remember when you have a decimal, all right, if it were just 0.5, it would be 5 over 10, right? If it were just 0.63, it would be 63 over 100, right? And if it were just 0.214, it would be 214 over 1,000. So when it's not repeating, you write it over a power of 10. All right, but the little trick I told you was if it is repeating, and again, this only works if the entire part is repeating, and I'm not going to ask you any that aren't, then it's over 9 or 99 or 999. So this would be 5 over 9. This would be 63 over 99. And this would be 214 over 999. But of course, it says to write it in simplest form because that's what we should always do with our fractions. Well, 5 over 9 is not going to simplify. But it looks to me like I can divide both of these by 3. In fact, I can get bigger than that, can't I? I can divide both of these by 9. All right. 63 divided by 9 is going to give me 7. And 99 divided by 9 is going to give me 11. All right, 214 over 999. I don't think that that one is going to simplify. All right, here we go. Solve each equation for x. Okay, so these two are squared equations. This is a cubic equation, and we're going to solve it by taking the square root, but we want both the positive and the negative square root. This one, we're going to take the cube root, and remember, when you take the cube root, it's just a single, because the cube root of a positive is a positive and the cube root of a negative is a negative. All right, but so when you take the square roots, you need the positive and the negative. All right, so then now I need to know, okay, what is the square root of 361? Is it a perfect square? Now, again, if you have it memorized, you're in good shape. If not, well, let's see here. Remember we did earlier, we did 20 squared was 400. Well, 400 is close to 361, isn't it? Well, if I go smaller, what's smaller than 20? It's 19. All right, well, I'm excited here because 9 times 9 ends up in a 1. Let's see, 9 times 9 is 81, right? So I get 171, and then I put a 0, and then I get a 1 and a 9, and I get a 1. 7 plus 9 is 16, and I get 361. All right, so the square root of 361 is 19, so it's plus or minus 19. X could be 19 or X could be negative 19. Let's skip over to this one. All right, these ones are a little bit easier to work with. The square root of 49 is 7, and the square root of 121 is 11, right? Again, this is a quotient of perfect squares, and I get plus or minus 7/11. It could be positive 7/11ths, or it could be negative 7/11ths. And finally, now the cube root of 1728. All righty. Now it's like, oh man, if I don't have this memorized, well, let's see here. Okay, well, what do we know? We know 10 to the third power is 10 times 10 times 10, which is 1,000, right? Well, it's bigger than 10, right? And if I were to go 20 to the third power, 20 times 20 times 20, all right, that's going to be 8,000. So I know it's between 10 and 20. And do you agree it's much closer to 10 than it is to 20? All right, so now I'm like, okay, well, I got to try something between 10 and 11. I'm sorry, 10 and 20, but closer to 10. I could try 11 times 11. Well, 11 times 11 is 121. And then I could do 121 times 11. But I see here that's going to end in a 1, isn't it? All right, so that's not going to work. All right, what about if I try 12 times 12 times 12? All right, or 12 to the third power. Okay, well, let's see here. 12 times 12 is 144. 144 times 12. I really should have pulled up. Do you guys remember back when we did the assignment, I gave you a list of perfect squares and perfect cubes? If I could go back in time before I started this video, I would have that available because that is perfectly acceptable for you to use. All right, so I'm liking this because 2 times 4 is 8. 2 times 4 is 8. 2 times 1 is 2. All right, then I put a 0 and I get a 1, 4, 4. All right, I get an 8. 8 plus 4 is 12. Carry the 1. I get a 7. All righty, so x is equal to 12. Now, again, it's not positive or negative 12 because this is a positive root. All right, a positive cube root. Well, I'm sorry, a positive number will have a positive cube root. A negative number will have a negative cube root. All right? Okay, and then finally a few more here. Write all the names that apply to each number. All right, this is a fraction. Therefore, it is rational. And if it is rational, then it is real. All right, what do we have here? Well, the square root of 100 is 10, so this is equal to negative 10. All right, is it a counting number? No. All right, is it a whole number? No. Is it an integer? Yes. All right, and again, it's not a counting number or a whole number because it's negative. If it's an integer, it's a rational. And if it's a rational, then it is a real, right? All right, 15 divided by 5, well, that's 3, isn't it? So guess what that is? That is a counting number or a natural number. It is natural. It is whole. It's an integer. It's rational. And it's real. It's everything that was on that diagram that we had, except for irrational, right? Because it can't be rational and irrational at the same time. And remember what I said about square roots? Square root of 21. 21 is not a perfect square. It's between the square root of 16, which is 4, and the square root of 25, which is 5. So it's a number that's between 4 and 5, but it's not a perfect square. Therefore, it's going to be irrational, and it's going to be real. Alrighty. Okay. Almost done here. 2 more sections. Compare, right? Less than, greater than, or equal to. All right. So let me ask you, what's bigger, 7 or the square root of 7? 7 is bigger, much bigger, right? What's bigger, 5 or the square root of 5? Well, so this is bigger than that, and that is bigger than that. But what's going to make this, the difference we're going to have here? All right, 7 is 2 bigger than that. All right, so square root of 7 plus 5 is going to be smaller. It's going to be smaller than 7 plus the square root of 5. What about 6 plus the square root of 8? And the square root of 6 plus 8. Again, if you look at these, you're going, well, wait, I understand that 6 is smaller than 8, all right? But actually, this one, but the square root of 8 is bigger than the square root of 6, but that's not going to be enough to make up for it, right? This is 2 bigger than that. And 8, the square root of 8, is not going to be 2 bigger. So once again, this is going to be smaller. Do you guys understand what I'm saying? The difference between 7 and 5 is going to be much bigger than the difference between the square root of 7 and the square root of 5. So the bigger square root is not enough to make up for the bigger whole number. All right, the square root of 4 minus 2, or 4 minus the square root of 2. Well, this one's a little easier to see because the square root of 4 is 2. 2 minus 2 is 0, right? This one clearly is not 0. The square root of 2 is not equal to 4. So this one is also less than. Wow, how fun is that? They're all less than. What's with that? They shouldn't have done that. All right, and again, my eraser is not working. All right, last part. Order the numbers from least to greatest. All right, this is sometimes going to be a little bit tricky because if these are super close, we could run into some problems. Again, this is where maybe judiciously we would use a calculator. But let's try to do as much as we can without a calculator. The square root of 81 is exactly 9. All right, so the square root of 72 divided by 7. All right. Well, does 7 go into 72 evenly? It does not, right? It's going to be 10, right? 10 and 2 sevenths. All right. 10 and, can you tell that's 2 sevenths? My eraser is just not wanting to work. 10 and 2 sevenths. There we go. And 8.9 as well. 8.9. Okay. All right. So if we want to put these from smallest to largest, this one wasn't too bad. All right. So 8.9 is the smallest, right? And then we have the square root of 81. And then finally we have 72 over 7. Square root, fraction, decimal. All right. This one may be a little bit trickier. We have 2.55. That is a decimal. Well, the square root of 7 is between the square root of 4 and the square root of 9. Well, the square root of 4 is 2. The square root of 9 is 3. So it's between 2 and 3, but it is closer to 3. All right, now let me ask you this. Is it more than halfway? Do you guys agree that the square root of 7 is more than halfway? All right, so this is going to be bigger than 2.55. Do you guys see what I'm saying? Square root of 7 is closer to the square root of 9 than it is to 4. So this one is going to be a little bit bigger than that one. And then what about 7 divided by 3? Well, if we do 7 divided by 3, 3 goes into 7 2 times, right? Put the decimal. 32.3. Okay. So this one is about 2.3. So do you see this one is the smallest? 7/3. And then these two are close, but we're going to say 2.55 and then the square root of 7. All right, and just to double, triple check, I'm going to use my calculator and I'm going to put in the square root of 7 and I get 2.64. All right, so this one, like I said, 2.64, it is closer to the square root of 9, which means it's more than halfway. All right, so real numbers, rational numbers, irrational numbers, integers. You got to know that kind of stuff and how they're categorized. You got to know how to compare numbers. Go back and find that perfect square and perfect cube paper that I gave you. Make sure you have access to that. All right. And calculators should be used as a last resort. You're kind of on the honor system here. You saw when I went to a calculator. Really, the only time you should be going to a calculator is when we get to the tenths. All right, and you have to compare things at the tenths or hundredths level. Then I don't mind using a calculator. If we had been in traditional school, there wouldn't have been any calculators at all. But as you know, we're not. All right, I hope this video was helpful for you. Good luck on the assignment and good luck when we take the quiz, everybody.